Hello students, this is a question of ATWOOD machine. In this arrangement you can see there is a pulley which is connected to the ceiling and a thread is passing over the pulley, and on the two sides we have two blocks of masses M1 and M2. Let's read the question. In the figure shown here, known as ATWOOD machine, two blocks of masses M1 and M2 are connected by a massless string which passes over a pulley fitted to the ceiling. If M2 greater than M1, that means this M2 heavier, then find the acceleration of the blocks and the tension in the string. Here T is the tension in the string. So first of all, let us decide that how the system will move. As you can see, M2 is greater than M1, that means this M2 is heavier. So therefore, due to the gravitational force, M2 block will fall down. So M2 will move downwards. And so at the same time, M1 will then rise up and both of them will have same acceleration A. Let us find out this acceleration. To find out this acceleration, we have to first of all draw the free body diagram of both the blocks. So M1G and M2G are the gravitational forces acting on the two blocks. Furthermore, the strings which are connected here at the top of the two blocks will exert tension force, and that tension force will be in the upward direction, because tension force can pull a body, tension cannot push a body. Now we have to write down Newton's second law for each of these blocks. Let's begin with the first one. As you can see here, that tension T is acting upwards and gravitation force is acting downwards, but acceleration is in the upward direction. So who is causing the acceleration? The tension T is causing the acceleration, and who is opposing the acceleration? M1G is opposing the acceleration. So the Newton's second law equation would be like this: T minus M1G is equal to M1A. Net force is equal to mass into acceleration. Now you may think that why net force is T minus M1G, why not it is M1G minus T, opposite way? Because acceleration of the block is upward direction, so therefore the upward force must be bigger than the downward force. That is why T minus M1G. Applying same logic to the second block M2, if you see here, then acceleration is in the downward direction, so therefore the force M2G must be bigger than the tension T. Therefore the equation for the second block must be M2G minus T is equal to M2A. Now that we have written both the equations, let us solve the problem. We have to find out acceleration A. Now we have tension T also in the same equations. We need to eliminate these tensions because we don't want to find tension now. We find acceleration first. So what we do, we first add both the equations. We add both the equations so that the tension T on the left hand side gets cancelled. Then remaining things are written like this. Take G common, we get M2 minus M1. Take A common, we get M1 plus M2. Then by rearrangement, acceleration A is equal to M2 minus M1 divided by M2 plus M1, the whole thing multiplied by G. This is a very important result and must be remembered. It can be remembered like this: difference of masses divided by sum of masses multiplied by G is the acceleration of the blocks. Now, next thing is to find out the tension T. For finding tension T, what we'll do, we will divide both the equations. First equation and second equation we divide. So dividing cancels the acceleration from both sides. And after that, we will cross multiply both the equations. So after cross multiplying, we'll get this equation. Now we want to find tension T. So this tension T and this tension T both should be on the same side. So transpose it on the left side. We'll get this, and the right hand side will become 2 times M1 M2G. Take T common from left hand side, we get M2 plus M1. Therefore, the value of tension T would be 2 times M1 M2G divided by M2 plus M1. And this is a very important result also. We should remember this result. These both the results, acceleration as well as tension T. Thanks for watching.